All right, this video is going to cover bottom-heavy rationals. So if you haven't already seen the attributes of rationals video, I'd highly recommend going and watching it so you kind of have an idea of where I'm getting some of these answers. Now, when I say bottom-heavy rational, I mean the degree of the denominator is bigger than the degree of the numerator. So like this one, the degree of the denominator is 2, the degree of the numerator is 1. So it's bottom heavy. And it doesn't always just have to be 1 degree higher. Like it could be multiple degrees higher. So like this one would have degree 3 on bottom, this one's degree 1 on top. It's just if the bottom has more, if the bottom is a higher degree, then it's considered a bottom heavy rational. Now, the first thing to know about bottom heavy rationals is all of their horizontal asymptotes, all these HAs, are going to be y equals 0. So I'm going to go ahead and fill that in on every single one of these. That is by far the most important thing to know about a bottom heavy. So there's going to be an asymptote along this x-axis. That wasn't very good. Let me try again. Okay. Now, I'm just going to focus on one at a time now because now it's a little bit different. There's almost like a checklist that you need to look for. You need to be looking for vertical asymptotes, you need to be looking for x-intercepts, and you need to be looking for y-intercepts. Let's start with vertical asymptotes. You get your vertical asymptotes for these by factoring the bottom and setting it equal to 0 and solving. So like this one would be x squared equals 0, and solving, you would get x equals 0. That's a vertical line. So this one has a vertical asymptote right on the y-axis. So this vertical asymptote was x equals 0. Okay, now you're going to need some information to put down on this graph before you're really going to be able to graph it. So here's what I mean. Go find your x-intercepts. You get your x-intercepts from the numerator of rationals. And again, you set those equal to 0. So like this one, 2x minus 1 equals 0. Solve this. This is going to have an x-intercept at 1/2. Right here is my x-intercept. Okay, there's no more factors on top. That was the only one, so I'm only going to have one x-intercept. Now, y-intercept, you get from plugging in x equals 0 into your original equation. So I'm looking at this original equation, and I'm plugging in 0 here for x. So if you notice, it's going to be a 0 on bottom here, which is going to mean that it's going to be divided by 0. So this is not going to have a y-intercept. So no matter what I draw my graph as, it will not have, it won't touch this. It won't have a y-intercept. Okay, this is basically all the information you get. However, there is one more vital piece of information. They're going to tell you on this vertical asymptote, if you look at this right here, the degree is 2. What that means is this rational, the lines are going to be going the same way on the other side of the vertical asymptote. So they could either both be going up or they could both be going down. They will not, however, be like this and go opposite. This is super important to know, and it's going to help you so much when you're graphing these. So the fact that it's degree 2 means that the arrows must go the same direction, either both down or both up. Now, I still don't really have enough information to graph this. So here's what I do when I don't have enough information. I realize that this is an equation, right? And I can just plug in a coordinate, like an x value, and it'll tell me the y value. So I could do this, y equals, plug in -1. you would get -3. This is a coordinate that you can plot. Now, that one dot right there tells me that this section of line is going to look like this. The reason I know this is because it can't touch this vertical line, so it has to go and level out down here. And it can't cross this, well, it technically can, but it's not going to cross that horizontal line. I know that because there's no x-intercepts right here. There's no x-intercepts that it's gonna, that say it's got to cross at. So I know that's that section of line. Now, since I know that, I know I have an arrow down here. And I know that this x squared part meant that these arrows are going to go the same direction. So if I have an arrow down here like this, I'm going to have an arrow down here like this on the other side. Now to finish drawing this graph, you have to hit that x-intercept. You have to cross at this point. So go and cross at that point, but you have to also level out at your horizontal asymptote. So you're going to cross and you're not going to do anything crazy like this. What's going to happen is you're going to cross and then you're going to level back down onto that horizontal asymptote. This is what the graph of this function would look like. It's weird, I know. That's okay. Let's move on. Look at another one. Let's do this one. The first thing you got to realize is this is not fully factored. You can't do a rational function unless it's fully factored. So go factor it. On top, you can take out a 2. So that's going to look like 2x minus 1. On bottom, they both share an x, but I'm going to take out a negative x, and I'll show you why. So I took out a negative x. The reason is because now I can look at this and realize these are going to cancel. When they cancel, it means I'm going to have a hole. So keep that in mind as we move forward. Okay, let's go down the checklist. Vertical asymptote, you get from the bottom being factored and setting each factor equal to 0. So I've got this negative x equals 0. That's just an x equals 0 vertical asymptote right here. And then this other one, if you don't recognize this hole, you'll call x equals 1 a vertical asymptote, which is not true. Since it canceled, it's a hole. It's no longer a VA. It's no longer a vertical asymptote. So I only have one vertical asymptote on this at x equals 0. Hope that made sense so far. Now, you have to also go get the x-intercepts. Well, look at the top. That's where you get your x-intercepts from, right? Well, the x minus 1 canceled. There's no more x's on top. There are no x-intercepts. You could go get the y-intercept. Basically, plug in 0 into your original equation. If you do that, you'll get divide by 0. That means there's not a y-intercept either. All there is this hole. It's at an x coordinate of 1. You have to go find the y value. To do this, all you got to do is plug in 1 into your original equation for all the x's. So that would look like this. My hole would be that y equals, plug in a 1, okay. If you look at what I'm about to do, I'm about to get a value of 0 on the bottom. If you plug in to your original equation for the hole, you're going to get it wrong. So I kind of just told you wrong. I'm sorry. You have to plug it into the new equation. So look at this. The x minus 1's canceled. So I need to plug it into just 2 over negative x, whatever was left after the cancel. So plug in 1. You would get 2 over negative 1, which is negative 2. I have a hole at 1, -2. I'm going to go ahead and draw an O there. All right, the last thing to think about before I actually start graphing this is this vertical asymptote. What are the arrows going to be like? Well, since at -x, the degree is just 1, that means, since it's 1, that means the arrows are going to be it's going to be opposite. It's either going to be like this, or it's got to be like this. They will not be going the same way like the previous problem. So here we go. In order to graph this, I would use the hole first. And I'd realize that it's got to hit the hole, this function. And it can't touch the y-axis. And it's not going to touch the x-axis. I know that because there's no x-intercepts here. So it's going to level off like this. Now, if this arrow is going down, that means this other section of line here, the arrow's got to be opposite. It's got to be going up. And this graph cannot touch that x-axis because there's no x-intercepts here. So it's just going to level off like this. Green would be my answer. Okay, moving right along. Look at the third one here. Go through this checklist, find your VAs. So you get your vertical asymptotes by setting each factor on bottom equal to 0 when solving. So this one is going to be at 3 and -2 because nothing canceled. So I've got a vertical asymptote at x equals 3 and at x equals -2. That's here at -2, and that's here at 3. So just looking at this one already, you have to fill each of these gaps, gap A, gap B, and gap C. Every single portion of this line that's on like either side of that vertical asymptote has to have a section of line to it. So I've got a little bit of work to do here. I'm going to keep going through my checklist though. I'm going to go look for my x-intercept. You get your x-intercept by setting the factors on the top equal to 0. So that means I'm going to have to go through the origin. And that's my only x-intercept. That's the only x on top. Y-intercept, plug in a value of 0 for your x. Well, if you do that, you'll get 0 on top over -6 on bottom. 0 divided by -6 is 0. Which you should have already known that because you're going through the origin. That's your y-intercept as well. Okay, now, this is basically all the information I have. The only more information I could really get from this is that the vertical asymptotes both have an exponent of 1. So that means whatever my line looks like, on the other side of that vertical asymptote, it's got to be oppo. They have to be opposite. So keep that in mind as you try to graph this. But if I get stuck here, like we are stuck, I don't know even where to start drawing this line. If I get stuck here, basically what I do is I plug in a point. Just like before when I plugged in this coordinate, I'm going to plug in a point. I'm going to use 1. If you do this, you'll get 1 over -2 times 3, which is -6. So I plugged in a point and I got 1. I got the coordinate 1 comma -1/6. That's here. Okay, this tells me a lot. I know it doesn't look like it tells me a lot, but it actually tells me a whole lot because I'm going to have an arrow up here. And the reason I know that is because this x-intercept here, it's not a bounce. It's an exponent of 1. So it's going to have to slice through. So I would have to slice through here like this. And if I slice through like that, then I've got to level off before I hit that asymptote. I have to go vertical before I hit that asymptote. I have to go through that coordinate. And then I can't cross that other asymptote like this. So I know that section of line. Now, that is so helpful to me because Now that I know this arrow, I know this arrow. You know what I mean? Since it's oppo on those vertical asymptotes, this arrow has to be up here. And since I know that, I now look over here, there's no x-intercepts here. I'm not going to cross anywhere. So go and just level off at your horizontal asymptote. Now, likewise, on this vertical asymptote here, I know this arrow. I know since this x plus 2 is degree 1, that my arrows are opposite, so I know there has to be an arrow right here. Again, I look for x-intercepts. There are none, so I'm not going to cross there. I'm just going to go and level out at my horizontal asymptote. This is what this one would look like. I know it's weird, and I know you're going to list out all these things. Just be advised, some of these times you're not going to have enough information. You're going to have to go solve for a coordinate, and then you'll have enough information. Okay, this last one, go get your vertical asymptotes, the bottom, set them equal to 0. So I've got a vertical asymptote at x equals 3 and at x equals -1. That's here and here. So just like the one before it, I'm going to have 1, 2, 3 sections of line that I have to figure out. But let's keep going down this checklist. The x-intercept here, take the top and set it equal to 0. So I'm going to have an x-intercept of 1. Let me do that in blue. So I know I have a dot here that since it's degree 1, I have to cut straight through at, okay? Keep that in mind. Now the y-intercept, go plug in 0 for your x's. If you did that, you would get -1 over -3 times 1. So y-intercept, you have -1 over -3 times 1, which is 1/3. So I know I have a y-intercept here. Now, also keep in mind that your vertical asymptotes are oppos because they're both degree 1. So that means if I know there's an arrow here, I know there's an arrow here. All right, let's go ahead and draw this one. Basically, I know I have to cut straight through that x-intercept, right? And I know I have to hit this y-intercept. So I'm going to cut straight through, and I know I can't cross this. So I'm just going to go vertical and level out. Now, on this other side, I'm going to level out here as well. Now that I know that, I'm going to look at my arrows. It has to be oppo on the other sides of these vertical asymptotes. So that means I'm going to have an arrow up here. And then I look for x-intercepts. There's none there. So I'm just going to go and level out on my horizontal asymptote. Now, this arrow is telling me that there has to be an arrow here because of that vertical asymptote being degree 1. And then I look for x-intercepts and there are none. So I just come up like this, and then I can do better than that. I come up like this. I did the same exact thing. 3rd time's the charm. I come up like this, and then I level out on the horizontal like this. Doesn't look pretty, but it's effective. Okay, so to recap, you need to be thinking about these 4 things every single problem. In addition to that, you need to be thinking about holes. You don't make the mistake that I did at first. Don't plug in your x value of the hole into the original. You need to plug it into the one after you've canceled. That's what this work is right here. That'll tell you the y value of the hole. One of the biggest mistakes I see kids make is they'll just put the hole right on the x-axis. You need to solve for that y value of the hole. Another thing to keep in mind is your arrows. Since this one had degree 2 on this vertical asymptote, that meant my arrows went the same way. Since this one over here, for example, they were degree 1 on the asymptotes, that meant my arrows went oppo directions. And sometimes you'll get stuck and not have enough information to actually graph it. When that happens, find an XY coordinate. Choose any one you want. You could have plugged in 5, it doesn't matter. But plug in an X value, get a Y value in return, and then plot that as a dot on your graph, and that will be more information, and you should be able to graph the line then. So these are bottom heavy, and if you can believe it, these are probably the easiest. So I hope this video helped.